This is a video for 10-6 notes, incomplete quadratic equations. All an incomplete quadratic equation is one that might not have a b value, might not have a c value, or might not have either. So the steps are above. We're going to rewrite the equation in standard form if we have to. Combine any like terms if we have them. Factor completely, which keep in mind means we are probably going to factor more than once. Set each factor equal to 0 and solve, and then we could check our solutions by taking them and plugging them in for x into the original equation. So notice number 1 is not in standard form. I want this right hand side to say 0. So to move that 6x to the left hand side, I'm going to have to subtract it. Remember, anytime you're moving something over an equal sign, you do have to do some sort of operation to move it. So we're going to get x squared minus 6x equals 0. We are in standard form now, so we can go ahead and start factoring. You want to go through that same process of factoring where you try to do a GCF first and then go from there. Hopefully you're noticing this has a greatest common factor of x. They both have an x in common. So if I divide each of those by my GCF, I'm going to be left with x minus 6 in my parentheses. Now I can't factor x or x minus 6 any further, and I know we're used to seeing our factors both written in a set of parentheses, and right now x is kind of like just on the outside, not in a set of parentheses. That is actually considered one of your factors, because remember, all a factor is something that you can multiply by another something to get the answer that you're looking for. So we're gonna t-chart here. Remember, you want your t-chart to break your factors up and then set each of those equal to 0. So we have x equals 0 and x minus 6 equals 0. Then your next step is just to solve for x. Notice that the left-hand side is already solved for x. You don't have any solving to do there. So one of your solutions is going to be 0. If I add 6 to both sides here, my other solution is going to be 6. And like I said, we could plug both of those into our original equation to check to make sure those are correct answers. On to number 2, I want to move this x squared on the right-hand side to the left-hand side by subtracting it to get this thing into standard form. Notice I can subtract that x squared right from the 4x squared. So if I have 4x squared minus an x squared, that gives me 3x squared minus 27 equals 0. Okay, that is in standard form. There's nothing else to combine, so I'm going to go ahead and factor. These have a GCF of 3. So I'm going to divide each of those by 3 to be left with x squared minus 9. Now notice up above that step 3 says factor completely, which like we said before, that means that you're probably going to factor more than once. Because if you look at the inside of the parentheses of what we have right now, x squared minus 9 is a difference of 2 perfect squares. So I can do dots there. Dot signs are always plus and minus. Square root of x squared is x. Square root of 9 is 3. Okay, I can't factor anything further, so I actually have 3 factors here. 3, x plus 3, and x minus 3. So I'm going to t-chart breaking those up, and I'm going to set each of them equal to 0. Notice the first part of my t-chart says 3 equals 0, which doesn't really make any sort of sense. Anytime you have a situation like this where one of your factors is just a number being set equal to 0, we're just going to disregard that. And then for the others, we're going to subtract 3 to get negative 3 and add 3 to get positive 3. So our two solutions are negative 3 and positive 3. On to number 3, 4x squared equals 49. Let's move that 49 over. Get this in standard form. Now, if you try and find a GCF between 4 and 49, the only one you're going to find is 1. But remember, we don't ever want to take 1 out as a GCF. So then we need to move on and say this is a binomial. So the only other type of factoring I can do is dots. This is a difference of 2 perfect squares. 4 is a perfect square, so is x squared. And 49 is a perfect square as well. So we're going to go straight to dots here. Plus and minus. the square root of 4x squared, take the square root of 4, which is 2, and the square root of x squared is x, so my first position is going to say 2x. Square root of 49 is 7. Now, once you get to this point, you should realize we cannot factor either set of parentheses any further. So we're going to go ahead and T-chart and set both of those factors equal to 0. Now, from here, you're still just solving for x. So we're going to subtract 7 first. 2x equals -7. And we just have one more step here to get x alone. We just have to divide by 2. You could just leave it as -7/2, or if you wanted to turn that into a decimal, it is -3.5. And then same thing on the right side, we're just going to add 7 and divide by 2 to get positive 3.5. Okay, next for number 4, this is already in standard form, so I'm going to go ahead and try and GCF factor the left side. GCF here is 9. So if I divide each of these by 9, I'm going to get x squared minus 4. Now, on the inside of the parentheses, x squared minus 4 is a binomial. It is a difference of 2 perfect squares, so we're going to dots that. Plus and minus. Square root of x squared is x. Square root of 4 is 2. And then we can't factor any further there, so we're going to do another one of those triple T charts. Set everything equal to 0. Again, we run into the situation where we have 9 equals 0. We're just going to disregard that as a solution. And then either just solve for x or remember that the solution is going to have the opposite sign as your factor. So we get -2 and +2. On to number 5. This one's a little bit different just because we're nowhere near in standard form. What we actually have to do for this one is cross multiply. So we're going to multiply 15x times x and 6 times 10. 15x times x gives us 15x squared. 10 times 6 gives us 60. But then again, I need to get this in standard form. Make that right side say 0. Again, try and GCF factor the left-hand side. GCF is going to be 15. Divide everything by 15 to get x squared minus 4. And then again, on the inside of the parentheses, x squared minus 4 is a difference of 2 perfect squares. So we're going to dots that to get x plus 2 and x minus 2. Do your T-chart. Disregard the 15 equals 0. We end up getting -2 and +2. I want you to try the last two on your own and check your answers on school.